So now, if you have noted time, this one.
Next time.
Oh, that's appeared. Last one.
Okay. And I request all of you to clap for our volunteers. Clap after getting loud. You have to. Okay, fine.
Say your name.
Use this mic and tell.
Yeah. One by one, say your name.
Which class you are?
Which class?
Which college?
Shantika, Government First Grade College, Honavar, BSc 6th sem.
Which semester?
Okay.
Chemistry.
Sixth semester. Sixth semester. Correction.
Computer science, physics.
Fatima from S.D.M. Degree College,
Okay.
class BSc 2nd sem.
What are the subjects you have?
Chemistry, Botany and Zoology.
Oh, super.
All subjects are nice.
Saujanya Ganpati Hegde from Dr. A.V. Baliga College of Arts and Science. I am studying BSc 6th sem, subject Physics Chemistry.
My name is Miriam Pereira from S.D.M. Degree College and I am studying BSc 2nd sem.
Okay. One more time, big round of applause for our volunteers. Thank you. One more is there. Women's Day, sir. Adakkoskara.
A.V. Ganesh, and I am from this college itself. I am studying BSc 6th sem, and my subjects are physics and chemistry.
Okay. Thank you very much. Thank you very much.
Now let me, at the end of this, let me show what chemistry or what is happening here.
Sir, one doubt here.
Yeah.
In the last slide, whether you had sodium sulfite or sodium thiosulfate. Fourth one, I mean.
Next one.
First, yes, fourth one it is.
This one.
Sir, I think it is not sodium sulfite. I think it is sodium thiosulfate.
Is it sodium thiosulfate?
Na2H2O3 is correct, I think.
Yeah. That's a typo here, but the correct one is in the previous.
It is a typo error. It is a typo error.
You go to the previous slide. Previous slide. Yeah, this one. This is the correct one. There is a typo there.
This is correct.
Yeah, that's one. Okay. Yeah, thank you for pointing out. Anyway, so if you have noted down the timing of the color to appear, and then concentration is given in the table, you just plot. In this case, you will find a plot with something look like this qualitatively. If that is what is happening, the order of the reaction will be the first order reaction. Okay? So this is first order with respect to potassium iodide. That is the reagent in the slow reaction, which is the red determining step, that as I mentioned in the earlier. So likewise, you can do other experiment, zero order or second order, and can find out the kinetics. Okay, let's move on. Other color related experiment. I have other chemical here.
White.
My white towel is just there. That's what? Which one?
Use this one.
Use this.
You can use that. You can here.
Vinayji, are you able to hear me? No. Huh? No. Now? Vinayji. Okay.
It's not through the mic, through your bare voice is coming. Mic is not being used.
Okay.
If they can hear, that's
Shout.
So are you able to hear me?
Yeah.
last.
The back side?
Yes, sir.
Okay. Super. Okay, now I have a dye with maybe some of you have heard about, or if not, it's okay. The dye called methylene blue. It's a very common dye. It should be in this. So I have dextrose here. Dextrose is one of the member of polysaccharide compound.
Andre glucose, sacre. Yeah.
Yeah, glucose in a way.
Glucose.
Glucose.
Sacre sucrose. ಇಲ್ಲ ಆದ್ರೆ ಸಕ್ಕರೆ ಹಾಕು ನಾಟ್ ಸಕ್ಕರೆ ಅನ್ನಕ್ಕೆ ಬರಲ್ಲ because it is chemistry. You have to be precise. Yeah.
Physics can be
Yes.
So what I am trying to do is, I want to convert glucose, that structure written is a cycle, one of the monomer of the previous structure. You saw amylose and this thing starts, right? Is a monomer of that in a way. Now, I want to open this ring and convert this to gluconic acid. And that is a simple reaction, but visually you won't see anything. Okay? To visualize that, we'll add another thing, that is the dye this I mentioned. So let's see how it works. So I have glucose, dextrose dissolved in this, in water, is a water soluble, right? What I eat, the things are water soluble. So now I am adding potassium hydroxide. This is again a common chemical,
KOH.
KOH. Is KOH acid or base? Base, right? Because it has hydroxide ion or component. By the way, the acid which have hydroxide, what is the name of such a base? Bases? Something called tronstate acid base. Okay, so now see KOH and glucose both gone. I don't see them. Perhaps the front rows can see that. They are not there. That means the solution has gluconic acid, not glucose anymore. But you don't see a visual change, right? So we don't believe that it had happened. Now, let me do a second step in this.
Sir, ಅದರಲ್ಲಿ ಎಷ್ಟು ಗ್ರಾಮ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ ಎಷ್ಟು ಗ್ರಾಮ್ ಆಫ್ KOH ಹಾಕಿದ್ದೀರಾ? How much the quantity?
It is 5 gram and 2 gram respectively.
Okay.
The glucose and potassium.
Note it down.
Okay.
5 gram of
So
glucose.
what you can do is take 150 milliliter water. Make sure that you take distilled water, not the tap water, because there are a lot of other things which might interfere with this. Then take 5 gram of gluconic acid, glucose, and 2 gram of potassium hydroxide. That will lead to formation of gluconicum or gluconic acid. This will be there. That's it. No. So here I have methylene blue. I am just adding 1 drop. It's a commercially available solution, but you can also make it. This dye basically is a solid, but you can make it in ethanol. So 1 drop I am adding. It is a blue. So expect the solution color to be blue. Okay. Now this color is just because dye was originally blue. Still we don't believe that gluconic acid has formed. Okay. But let's see what happens next, and then only we can conclude that it is happening.
Observe carefully.
So on the screen I have written, if there is a gluconic acid formed, it will reduce methylene blue. Here I have drawn that picture. Here. This is the structure of methylene blue, where we have 3 benzene rings or benzene ring and a heterocyclic ring conjugated, okay? And that leads to blue color. But when there is the reducing agent there, in this case gluconic acid, the middle ring gets reduced. The addition of proton is reduction. Okay? So
you
now,
can see that bottle.
what was the color before? You could see that, right? Maybe in the back row may not be able to see, so I'll bring it there. So now you see that once reduction happens, this is what is not anymore blue, right? But you can do one thing. You can make it blue again. Okay. So what I did, you see the first step, that water, in tap water or distilled water, is there oxygen? Plenty of oxygen there, right? That's how the aquatic animals survive, right? Like distilled water which has oxygen. Also there is an empty area which has oxygen, right? This oxygen reacts with this thing and oxidizes. Are you aware of redox reaction? Reaction which have reduction and oxidation bonds. So this is that kind of reaction. For reduction you need gluconic acid. For oxidation you need oxygen. So now I am doing again. Reaction with oxygen is not easy. You have to set it well. So you begin. Okay? Now you leave it. You leave it again. This top reaction will proceed. Are you able to see color? Maybe that light problem.
Now it is turning
It's
into
gone.
the colorless.
It was blue, is not anymore blue, right? So, this reversible, I drawn two arrows forward and backward. That is the indicator of what? It is a reversible reaction, right? When arrow lengths are equal, you say it is forward and backward reactions are equally running, right? That is an equilibrium step. So, you can keep doing this. Maybe some of you, this is not anymore, so not toxic, you can try, okay? If you want to try, just try. No problem. There is glucose in this.